All right, welcome to The Explainer. Today we are tackling a huge idea in mathematics, integration. But we're going to make it super simple, thanks to some key ideas from a really clever lecture. And trust me, it's a concept that once you get it, kind of changes how you see everything. So let's jump right in.
So let's start with a puzzle. Imagine you need to measure something, but the thing you're measuring is always changing. It's not a nice, neat, constant value. How on earth do you do that?
To really get what I'm talking about, let's use a simple example. Picture this. You've got a bunch of salt boxes lined up in front of you. Your job? Figure out the total amount of salt you have.
Now in the easy-peasy version of this problem, every single box is filled up perfectly, right to the top. Calculating the total is a piece of cake, right? You just multiply how many boxes you have by how much is in one box. Done. Super simple.
But what if it's messy? What if one box is half full, the next is almost empty, and another one is overflowing a bit? All of a sudden, that easy multiplication trick is useless. It just doesn't work. The amount is changing all over the place. So what do you do now?
And this is where the lecture I mentioned comes in with this just genius solution. And the best part, it has nothing to do with complicated math formulas. It's pure, simple, common sense.
Think about it. Instead of driving yourself crazy trying to measure every single weirdly filled box, what if you just took all the boxes and dumped all the salt into one big container? You just combine all those little messy parts into one big pile, and then you just measure the total. Boom! Problem solved. You just summed it all up.
And that right there, that simple idea of summing up, well, that has a fancy mathematical name: integration. That's all it is at its core. It's the tool you pull out when simple multiplication won't work because things are always changing. You just add up all the little tiny pieces to find the grand total.
Okay, so now that we get the basic idea, how does this whole summing tool actually work in the math world? Well, it kind of comes in two main flavors, and it really just depends on what kind of question you're trying to answer.
First up, you've got what's called indefinite integration. Think of this as the general recipe. It's not about finding a specific number. It's about figuring out the process or the formula for adding things up. Then there's definite integration. This is exactly what we did with the salt. It's all about finding a specific, concrete number. It answers the question, exactly how much is there between this point and that point? You know, like the total salt from box number 3 to box number 10. You get a definite answer.
All right, measuring stuff that's already there is cool, but this is where the idea gets really mind-blowing. We can actually flip this whole concept around and use it to build things, really complex things from scratch.
So, to build something, you need a building block, right? Like a Lego brick. In the world of integration, our building block is called the element, and you have to imagine it as the tiniest, thinnest, most basic slice of whatever it is you're trying to make. The lecture used a great example for this. Let's say we want to build a solid metal rod. What's the absolute simplest slice of a rod you can imagine? Well, it's basically just a super, super thin coin, right? That little coin, that's our element.
Now, one of these coins on its own is, well, it's almost nothing. It's so thin, it basically has no height. But what happens when you start summing them up? When you start integrating them? You stack one on top of another, and another, and another.
And before you know it, by adding up a huge, like an infinite number of these tiny little coin elements, you've built a whole solid rod. You literally just created a complex object out of an infinite number of simple little slices. How cool is that?
And this just shows how powerful this way of thinking is. It works for anything. How would you build, say, a flat disk? Well, you'd start with a tiny little ring in the middle. Then you add a slightly bigger ring around it, and another, and another. It's almost like you're making one of those spiral jalebi pastries, building it from the inside out. You just sum up an infinite number of rings, and poof, you've got a solid disk.
You see what's happening here? This is a huge shift in how we see things. We're moving away from a world of simple, separate, countable blocks, like our first salt example, and we're jumping into the real world, the world of smooth, continuous, flowing things that are all around us.
So, if there's one thing to take away, it's this. Integration isn't just some boring tool from a math textbook, it's basically a superpower for understanding anything complex. It teaches you that you can take the most complicated shape or system, break it down into its simplest, tiniest pieces, and then understand the whole thing by just adding them all back up. And that is why this matters so much. This isn't just theory. This is like the hidden engine behind our entire modern world. Integration is the bridge that lets us understand anything that changes smoothly. It's how engineers figure out the flow of air over an airplane wing. It's how physicists plot the path of a satellite going into orbit. It's the one tool that lets us take the messy, complicated, always changing real world and actually make sense of it, to measure it and to build with it.
So there you have it, a new tool for your brain. The power to see a complex problem, mentally slice it into a million tiny pieces, and then add them all back up to understand the whole. So my question to you is, what complex problem would you want to solve by slicing it apart?